Solve by substitution. Y minus 4 equals 2x, and 4x minus 2y equals negative 8. The easiest variable to isolate is the y in the first equation because it doesn't have a coefficient that we need to divide by. To get y alone here, we just need to add 4 on both sides, and we get y equals 2x plus 4. Now, because y equals 2x plus 4, in the other equation, wherever we see a y, we can replace it with 2x plus 4. So we have 4x minus 2 times y, but y is the same as 2x plus 4, equals negative 8. Now, on the left-hand side, we can distribute the negative 2. So we still have the 4x, but then we end up with negative 4x minus 8 equals negative 8. Now on the left, 4x minus 4x is 0. Those like terms cancel, and we're left with negative 8 equals negative 8. This is interesting, because in the previous problems, when we used substitution to solve, we ended up with something like x equals 2, or x equals 0, or x equals negative 5. And here, we end up with negative 8 equals negative 8. This is a true equation. And we have to figure out how to interpret this. Now, we're not going to say all real numbers, which is something that we've done in the past when we had a true equation, because we know that the solutions to a system of equations like this, the solutions won't be numbers, they'll be points. But you might be remembering now a situation like this when we graphed. There was a situation where we thought maybe the answer might be all real numbers, but instead it was infinitely many solutions. And that happened when we had the two equations that gave the same line. When we get a true equation here, this means that the equations have identical graphs. Basically, they are the same line. And if you remember, in the situation where we ended up with the same line, we said there were infinitely many solutions. Which is going to be the answer here. Anytime we have a true equation, what that means is that when we graph the two lines, they end up being the same exact line. And when that happens, we say there are infinitely many solutions.